Good morning and welcome to lesson 5.6. This is an exciting day for all of you because this is the last lesson of the quarter and it's also the last lesson of the semester. So yay for us. Lesson 5.6, graphing inequalities in two variables. Well, the first thing, before I even start this, I just want to take a minute or two and I want to remind you that when we graph an equation in y equals mx plus b form. So I've given you a packet. The packet is probably more extensive than it needs to be, but I'm going to give you a few things here to help you remember. When an equation is in the form of y equals mx plus b, m is the slope, which measures the slant or the steepness of a line, and b is the y-intercept. That is where the graph crosses or touches the y-axis. So if I asked you to graph y equals 1/2 x plus 3, you should all be able to identify m, my slope, and b, my y-intercept. What's my slope, class? 1/2. What's my y-intercept? When graphing an equation of a line in slope-intercept form, which is y equals mx plus b, we always graph the y-intercept first. Please remember, the y-intercept gets graphed on the y-axis. From that point, I use my slope. My slope, is it positive or negative, class? So that means I am going up the ladder or up the y-axis. My slope is 1/2. I'm walking up 1 and over 2. You'll have a ruler when you take your quiz. Please extend the line to make sure you're not just giving me a itsy bitsy teeny line, but go ahead and extend it. So that's basically what you need to be aware of. Okay? Now let's just do two exceptions to the rule. Let's say if I gave you y equals -5. Y equals -5. So on each of these, you'll have an equation. You'll have a little graph that'll look just like this in your packet. And then next to it, it'll say, what does m equal? What does b equal? So y equals -5. If you know, raise your hand. Tell me what type of a line it is. Y equals a number is always what type of a line? Anybody? Thank you. Y equals a number is always a horizontal line. So y equals -5, you're going to come down 5, and you're going to draw a line like that. And here is y equals -5. Now we have two more questions to answer. Who could tell me what's the slope of y equals -5? Yes, thank you.
0.
Good, because all horizontal lines have 0 slope. And what's the y-intercept of this line? Well, look at the y-axis. Where does it cross, guys? And there you go. Are you with me? Did I go too fast? Okay, so there's 12 questions. Okay, this is a great lead-in for what I'm teaching today. Let's do one more exception to the rule, which is x equals a number. X equals a number is always a vertical line. So I get them confused. Then just learn one and the other one is the opposite. So let's graph x equals -2. X equals -2. X equals -2 is a solid line at -2. I'm going to drop it right there. Now, you should remember, because we spent a lot of time going over this, what kind of slope do vertical lines have, class? Undefined. So make sure that if you're answering this part of the question, that you make sure you give me an answer. Don't leave it blank. It is undefined. And what's the y-intercept of a vertical line? It's not 0. There is none. Don't put 0. 0 is a number. There is none. Does x equals does this vertical line cross the y-axis? No. All right. So that's a great lead-in. So now I can teach what I need to do today. So let's go back to our lesson 5.6. The solution set of an inequality that involves two variables is graphed by graphing a related linear equation. That equation forms a boundary or a half plane. It's actually going to take and it's going to cut our coordinate plane into two halves. The graph of the ordered pairs that makes up the solution set of the inequality, we fill in that region, okay? So, step number 1, always make sure that your inequality is in the form of y equals mx plus b. So that means that some of these you're going to see tonight in your homework are in standard form. So always put them in y equals mx plus b. Always identify what m your slope is and b your y-intercept is. Decide, is your line going to be solid or dotted? If you use the wrong line, there's no credit. If the symbol is less than or greater than, meaning it doesn't have a solid line under it, you graph it with a dotted line. If it's less than equal to, greater than equal to, that means it has a solid line underneath it, and you graph it with a solid line. Step 4, you can use the chart below, or you can choose 0, 0 as a test point. So let me just go on and just take this a little bit further. Now, if it's y equals a number, or if it's just y is less than a number, y is less than equal to a number, y is greater than a number, y is greater than equal to a number, remember it's a horizontal line. We just talked about that. If it's x is less than equal to, x is greater than equal to a number, remember you'll graph it as a vertical line. But please remember and be sure if your line is supposed to be dotted or solid. All right, so let's just take a look because I'm going to trying to make your life easy. So how do I know which way to shade? Good question. If the symbol is greater than and your line is a diagonal falling from left to right, your line is dotted, you're going to shade above the line. If your line is solid and it says greater than equal to, again. Now what if your line is rising from left to right and it says greater than or greater than equal to? That's what I want to make sure you understand which way you're going. Now if your line again is falling from left to right, meaning the slope is negative and the symbol is less than or less than equal to, you're shading underneath or below the line. What if I have a vertical line? If I have a vertical line and it says greater than or greater than equal to, that's pretty easy. You're going to shade to the right. If it's less than equal to, you're shading to the left. And if it's a horizontal line and it's greater than equal to, you shade above. If it's a horizontal line and it's less than equal to, you shade below. So I will allow you guys time to copy this later, but here's the whole thing, shading when graphing inequalities. Now there is a chart in your notes, and it tells you exactly. We did look at that a couple of minutes ago, so let's just look at it one more time. So here is your chart and your general rules on how to graph. Okay? And we just went over those. But I will allow you guys to copy that in a few minutes, but that'll just take up a lot of time right now while we're recording. All right, so let's just jump right into it, and let's go ahead and try an example. Graph each inequality. Well, let's go ahead and try y is less than 4. Y is less than 4. Example 1. Y is less than 4. So the first thing that you need to know, guys, is you need to know is what type of a line it is. Y is less than 4. So is my line dotted or solid? Okay, this is not in y equals mx plus b form. This happens to be an exception to the rule. So is my line horizontal or vertical? Horizontal. So to graph this, and you can graph it right in your notes, it's right there. There's a little spot for you to graph it in. Y is less than 4 is a dotted line at 4. Does that make sense? Hello? Yes. So that's what it's going to look like. Now it says less than. Numbers that would be less than 4, would they be above or below the line you just graphed? Below. So this is what your solution would look like. Are you with me? Okay. Does anybody have a question? Okay, example number 2. Example 2 is x is greater than or equal to 1. X is greater than or equal to 1. So tell me what kind of a line it is, solid or dotted. This is an exception to the rule. Which way is my line going? It's a solid line. Is it horizontal or vertical? Vertical. So I'm going to graph x is greater than or equal to 1. You did this last year, so I'm going to make a solid line at 1. I'm going to change the color so we don't get confused with what is my coordinate plane and what's my line here. So here's 1. And greater than 1 would be numbers. Which way should I shade? To the right or left? Right. If it's greater than, you're shading to the right, guys. Okay? And that's good enough. You don't have to get totally carried away. Okay? All right, let's try some that are going to be in y equals mx plus b form. What if I gave you one like this? Example 3. Y is less than or equal to 1/2 x plus 4. So identify my m, my slope, and b, my y-intercept. What's my slope, guys? What's my y-intercept? Good. What kind of a line am I going to draw? Solid or dotted? Why? Good job. So my y-intercept is 4. 1, 2, 3, 4. So there's my y-intercept. My slope is 1/2. So should I go up or down? Up 1 and over 2. And you told me a solid line?
Yes.
Okay, so there it is. We'll just pretend that went through. And now I have to shade. So this is the part where people forget. They do the line, but then they forget to shade it. No shading is no credit. So now my solution is everything, listen carefully, you choose. Is it everything above or below the line? Below. Good job. Is everyone with me? Yes. If it's less than or equal to, less than would be underneath the line that's given. If you don't understand, then look at me. You can always pick a test point. A great test point, if your line does not go through 0, 0. So let's plug 0, 0 in. So if you have to use a test point, I believe this is the way you were taught in pre-algebra, although I know Mrs. Raines also taught you this way. So if you pick the point 0, 0, okay? So you plug 0 in for y is less than or equal to 1/2 times 0 plus 4. 0 is less than or equal to 4. If that is a true statement, then you want to graph in the direction of 0, 0. If that was a false statement, then you would graph or shade in the opposite direction. Does that help? Okay. Let's try one that's not as friendly. So let's try one that's not in y equals mx plus b form. So let's do this. 2x, this is number 6 in your notes. 2x minus 3y is less than or equal to 6. Cardinal rule, always, number 1, get in y equals mx plus b form. So we have a little math to work here. So we want to solve for y. So what's the first thing I should do to both sides of these if this equals? Subtract 2x. And now I'm going to get negative 3y is less than or equal to negative 2x plus 6. What do I do next, guys? Am I going too fast? I want to make sure everyone's with me. Could you guys look up here? Okay. Let's remember something that I told you at the very, very beginning of this chapter, and that was when you multiply or divide both sides of an inequality by a negative number, you must remember to flip the inequality symbol. So this is going to become y is greater than or equal to 2/3 x minus 2. You have to get it in the correct form. Now you can graph it and shade it. So what's my slope, guys? It's not negative, it's positive 2/3. And what's my y-intercept? Good job. So here we go. Let's come over here and graph it. My slope is 2/3, which means I'm going up 2 and over 3. Is my line solid or dotted? How do you know it's solid? Good job. And we'll just pretend that I went through, so I'll just darken them because it's hard to use a ruler when you're drawing on the tablet for some reason. Okay, it says, so now my final answer here is greater than or equal to, so which way should I shade, above or below? And that, my friends, is how you do it. That's it. It's pretty easy. All right, I want to draw attention to one last page. I'm wondering if this got in your notes or not. I'm not sure. Yes, it did. Okay, Chapter 5, Helpful Hints to Remember, from Mrs. Urso, because she loves you. Remember, when graphing, to get the variable to the left to help you graph it correctly. When you multiply or divide by a negative number, please remember to flip the inequality symbol. Multi-step inequalities, variables to the left, numbers to the right, undo addition and subtraction, then undo multiplication or division. Again, remember, if you multiply or divide by a negative number, to flip, flip, flip. Solving compound inequalities, and is the intersection of the two graphs or what they have in common, or is the union like a wedding? Dun, 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 dun. It's all of both graphs. Absolute value sentences. There are 3 types: absolute value equations and inequalities. Each of these has 2 cases. The greater than symbol meaning great or, and you graph it as a union. The less than, and you graph it as an intersection. And then graphing inequalities on the coordinate plane, I just gave you everything you needed. Are there any questions? That's a wrap. We'll see you next semester, guys.